All right, so yeah, the plan is to start with a quiz, but I'll show, I guess, a little bit of mercy, and I'll start with allowing for 2 questions over homework. So I said the quiz is going to cover 2.6 and 2.7, so you might want to ask me a question from 2.6 and then a question from 2.7, just so you can recall what it is you were doing in those sections. So, any requests? From 2.6, 2.7, number 6, 11. Okay. So we're looking at page 133. Number 11, it says, if a snowball melts so that its surface area decreases at a rate of 1 centimeter squared per minute, find the rate at which the diameter decreases when the diameter is 10 centimeters. So the first thing that I'm looking at is all my units to make sure, it's all in the same units. They're all in centimeters, so I'm happy about that. I'm going to draw a picture. I have a snowball. So I'm going to assume that a snowball is a perfect sphere. It's melting, so it's melting evenly. So it's going to stay a sphere the whole time. And I have basically 2 situations here. I have the general picture of what's happening, and then I have the instant in time that they're asking me about. So they want to know what's happening. Says find the rate at which the diameter decreases when the diameter is 10 centimeters. So I'm going to draw a diameter across this thing. At the instant in time they're asking, that's 10 centimeters. But in general, that diameter is changing as it melts. So I don't want to fix it at 10. I want to call it something else. I'll call it capital D for diameter. Make sense so far? Questions? Now let me write down what's given and then what I want to determine. And you don't have to do these in any particular order. It says to find the rate at which the diameter decreases. Rate means derivative, right? So the rate that the diameter decreases. So that's the derivative of the diameter with respect to time. That would be what I want, right? That's the speed of the speed that the diameter is changing at. I want that at exactly the moment that the diameter is 10 centimeters, right? And I'm given what? Okay, the rate, what's decreasing at? The surface area, right? So I'm given the change in area with respect to time. Now, I could use SA for surface area. I'm just going to use A, and we all understand that's the area of the sphere, right? That's what I want. And that should be all I need to get going here. What's the next thing you do after you write down what you're given, what you want, after you draw your pictures? What do you need to come up with? An equation that connects what to what? dA, which is the area, right? I need to connect the area to the diameter. So do we have a formula that connects the area of a sphere to its diameter? So I go back to my formulas. And the only formula I have in the book says under sphere that the area of a sphere is equal to 4 pi r squared, right? 4 pi r squared? That's the only formula I have. However, I know the relationship between radius and diameter, don't I? I mean, we all should know that If you take twice the radius, you get the diameter, right? So if I solve this for radius, the radius is half the diameter. I mean, that's another way of saying the same thing, right? So I could come back to this formula, area equals 4 pi, but instead of r squared, I could put 1/2 d squared. And then go ahead and square 1/2. 1/2 squared is 1/4. That 1/4 will multiply times the 4 out front and go away, won't it? And you'll just have pi times diameter squared. That make sense? Square the 1/2. That cancels out the 4 in front. Then you do have to square the d, so you get d squared. So now I have a formula, don't I? An equation relating the two variables that I want to try and find derivatives of. So what do I do with that equation? What do y'all think? Plug in? Diameter? Not yet. You must do what first? Differentiate. Okay? Remember, the order that we do that's important. You don't stop the snowball from melting, right? You don't stop it and then say how fast is it changing. You take the derivative, treating the diameter like a variable, and then after you find the derivative, then you go say, okay, I'm going to stop it and plug in 10 for d. So what is the derivative of this? dA dt is the left side. Good. Pi is a constant, right? So pi, what's the derivative of d squared? 2d, chain rule, times d, d, dt. Y'all remember the DDT? It's a wrestling move, isn't it? I used to do that to my brother all the time. DDT. Any questions on how d squared becomes 2d dt? No? Okay, now what we wanted in the problem, right? The question was, what's d dt, right? That's what we wanted to know. So I'm happy that it appears here. Do I know dA dt in the problem? That's part of my given, isn't it? Oh, wait, hold on. Do I have this backwards? Oops, I said it the wrong. Why did I put question marks on both of those? Why didn't y'all say something? Okay. dA dt, see how I put the question mark there? Actually, that's not a question. What was it in the problem? What was it? 1 centimeter squared per minute. Okay, sorry about that. I accidentally wrote a question mark there. So we do know dA dt. We want to know dd dt. And do we know what d is? 10. See, now we can plug in the 10 at this point. So we should just be able to plug everything in. I'm going to plug in 1 equals pi times 2 times the diameter, which is 10, times dd dt. Oh. How do I do this? Is that okay? One divided by 20 pi equals dd dt. And we'll go ahead and figure out what that is on a calculator. We'll just get a decimal approximation. And then divide 1 by that, and you should get something like 0.01592 is approximately dd dt. And how is this measured? How do you measure this quantity? I mean, that's a speed, right? That's a speed that the diameter is changing. The diameter is measured in what? centimeters, right? And time is measured in minutes here, right? So this should be, the unit next to this should be centimeters. Ooh, that's too thick. Centimeters per minute. Does everybody have their formula sheets that have the different shapes on them? Because you're going to need it today. If you don't have them memorized, then you'll need it for the quiz. Okay, anything else out of 2.6? I won't do another 2.7 one. 2.6, number 11? All right, good one. So this is page 127, number 11. We have tangent of x over y equals x plus y. And you're supposed to find dy dx. That means that we treat x like our independent variable. We treat y like it depends on x. So anytime we take derivative of like x, it would be 1, but anytime we take derivative of y, it would be y prime, right? So on the left side of this equation, here I come with my differentiation. I have to use what rule on the left side? Chain rule. And then inside the chain rule, I actually have what? Quotient rule. So let me start with the chain rule. What's the derivative of tangent of something? Secant squared of that junk, which is x over y. Now times the derivative of what's inside. So derivative of what's inside, I'm going to use a quotient rule, right? You don't just take derivative on top and bottom, right? Someone's not going to do this, 1 over y prime, right? Derivative top and bottom separately, that is not what you do. Quotient rule says derivative of the top times the bottom minus derivative of the bottom, y prime times the top, all over bottom squared. That completes the differentiation on the left side. On the right side, you have equals what? 1 plus y prime. Okay, so let me try and clean this up. I have secant squared x over y times here, how about this? 1 over y minus y prime x over y squared equals 1 plus y prime. What did I do there? I just separated this, right? I took that and I just separated it into two fractions. I had y over y squared, which became 1 over y. And then I had y prime x over y squared, which is the other side. Now, the reason I did that is because I'm trying to get y prime by itself, right? Trying to get my y primes together on one side of the equation. Before I can do that, I must distribute this whole thing through this parentheses. So I split what was in the parentheses into two terms so I could distribute it. Does that make sense? So what I get here is 1 over y. I'm just going to stick that in front of that secant, right? You cannot put that 1 over y in there with that x over y. And then I have minus y prime x over y squared secant squared x over y equals 1 plus y prime. So all I did was just distributed, right, the secant squared through. Now I'm going to move all my y primes to one side and everything that doesn't have a y prime to the other. I'm actually going to move the y primes to the right because I have a minus on that y prime there. So when I move it to the right, it'll become a plus. That's just my preference. It wouldn't be wrong to go the other way. No. Oh, yeah, I'm leaving this one on this side. I'm going to bring the 1 from the right side to the left. I'm leaving the y prime on the right, but I'm bringing that other y prime over.